We'll start in about 1 minute. Today we'll cover section 8.6 on how to solve equations with radicals, and we will also cover section 8.8. That's the introduction to complex numbers. And about 40 minutes past the hour, I'll email you the quiz 8. And so complete the quiz 8, take a picture of it, and send it back within 15 minutes after receiving it. Next Friday, 1 week from today, we'll have a test over chapters 7 and 8. Next week, we'll have time to review a couple of days for test 3. Okay, so we'll get started with section 8.6 on how to solve equations with radicals. Okay, it will be explained how to solve equations with radicals. After solving an equation with one or more radicals, it is important to check the answers because of the possible occurrence of extraneous solutions. An extraneous solution is a solution that emerges from a process maneuver that is not a solution to the original equation. Okay, so we'll start with the first problem. Solve the following equations for the variable and check answers. We have the square root of 3x minus 5 equals 8. And we want to solve for x, but we see that x is inside a square root. Okay, so since it's inside a square root, we can get it out of the square root if we square both sides. So if we raise the left-hand side to the second power and raise the right-hand side to the second power, then the left-hand side just becomes 3x minus 5, and the right-hand side is 64. And in this case, we have a simple equation to solve. Add 5 to both sides, we get 3x equals 69. And then divide both sides by 3, we get x equals 23. And then we'll check in the original equation, replace x with 23. So we get the square root of 3 times 23 minus 5. Then do the arithmetic. 3 times 23 is 69. And then the square root of 69 minus 5 is the square root of 64. This is the principal square root, so it's positive. The positive square root of 64 equals 8. And since that matches what we began with, that verifies that x equals 23 is the solution to that equation. I'll just mention a property that we applied. If we square the square root of something like x, then that's going to simplify to x, but I'll explain it in a couple of steps. The square root of x squared means to multiply the square root of x times the square root of x. And the square root of x times the square root of x is the square root of x squared, because x times x is x squared, and the square root of x squared is just x. Okay, the next example, solve the principal square root of 4x plus 5 equals negative 5. Okay, the principal square root is a positive number. There's not a negative sign out front. So the left-hand side is a positive number, and the right-hand side is negative. But it's never true that a positive number equals a negative. So we can tell right from the start that this equation has no solution. So we'll just say no solution. If you don't notice that, you can still make it work. So if you square both sides, we'll go through the process. And this will illustrate why it's important to check your answers. So if we square the left-hand side and square the right-hand side, when we square the square root of 4x plus 5, we get 4x plus 5. And on the right-hand side, when we square the number negative 5, we get positive 25. And then we solve this equation, subtract 5 from both sides, 4x equals 20. And then divide both sides by 4, we get x equals 5. Okay, and then when we check the answer in the original equation, replace x with 5, so we get the square root of 4 times 5 plus 5. But don't forget, this is a positive square root. So this is the square root of 20 plus 5, the positive square root. And the positive square root of 20 plus 5 is the positive square root of 25, which is 5. But that does not equal negative 5. So either recognize right from the start that there's no solution, or if you don't recognize it, then you can still have the right conclusion that there's no solution. Okay, on the next example, this illustrates something that we want to make sure that we always do. We want to solve the square root of 5x plus 4 and then plus 2 equals 9. Before squaring both sides, we want the square root to be by itself. So the preliminary step is to subtract 2 from both sides. And when we subtract 2 from both sides, we'll get the square root of 5x plus 4 equals 7. And now we can square both sides. So we square the left-hand side. The square root of 5x plus 4 squared equals 7 squared. And when we square the square root of 5x plus 4, we just get 5x plus 4. And when we square 7, we get 49. And then this equation is easy to solve. Subtract 4 from both sides. We get 5x equals 45. And then when you divide both sides by 5, you get x equals 9, because 45 divided by 5 is 9. And then we'll go back to the original equation. Or this one is okay, either the original or this one. So replace x with 9, we get the principal square root, or the positive square root of 5 times 9 plus 4, and then plus 2. I'll use the original equation. Then simplify what's inside this square root. So 5 times 9 is 45, and 45 plus 4 is 49. So the positive square root of 49 plus 2 equals 7 plus 2. and 7 plus 2 is 9. So that agrees with the original equation. So that does mean that x equals 9 is the solution. Okay, that gets us started. We'll look at some more examples that are going to be a little bit more involved. Okay, so on this one, we want to solve the square root of x squared minus 9x equals 6. The square root is by itself on the left-hand side, so we can just square both sides. So we're going to square the square root of x squared minus 9x. And that's equal to 6 squared. Then when we square the square root of x squared minus 9x, we just get x squared minus 9x. And 6 squared is 36. So then we subtract 36 from both sides. And we get x squared minus 9x minus 36 equals 0. We can solve this equation by factoring. So we want to, if you want to use the AC method to see how to factor this, multiply 1 times negative 36. So we can review the AC method. So 1 times negative 36 is negative 36. And we want to see if we can find two integers that have a product of negative 36 and a sum of negative 9. So that means the one with the largest absolute value is negative. So this is the first pair. And then we test 2 times negative 18. Those add up to negative 16. Positive 3 times negative 12. Those add up to negative 9. So it is factorable with integers, integer coefficients. So 3 and negative 12 are the two numbers we need. So let's go through the entire process of factoring using the AC method. So in the next step, we'll replace minus 9x in the middle with either plus 3x minus 12x or minus 12x plus 3x. Either way works. But I'll go ahead and write it as x squared minus 12x plus 3x minus 36 equals 0. And then we factor by grouping. Out of the first two terms, factor out x. So we get x times x minus 12. Bring down the middle operator of addition. Out of the third and fourth terms, factor out 3. So we get x minus 3 times x minus 12. Then we factor out the x minus 12. And the two factors are x minus 12 and x plus 3. The product is 0. Okay, so the two solutions to this equation are x equals 12 and x equals negative 3. But we need to check to see if they are solutions to the original equation. So we'll check 12 first. So we have the square root of 12 squared minus 9 times 12. And that is the square root of 144 minus 108. And 144 minus 108 is 36, and the principal square root of 36. Principal square root of 36 is 6. Okay, and that's exactly equal to what it's supposed to be. So x equals 12 is a solution. And now we check to see if the other number, -3, is a solution. So in the original equation, replace x with -3. So this time we have the square root of the number -3 squared minus 9 times -3. And then do the arithmetic inside the square root. When we square the number -3, we get 9. And when we subtract -27, we add 27. So this is the square root of 9 plus 27, which is the square root of 36. And that's also equal to 6. So both of those numbers are solutions. Both 12 and -3 are solutions. Okay, the next example is a little bit more involved yet. But we have the square root of x plus 7 by itself on one side. So we can start by squaring both sides. So we'll square the left-hand side, square the square root of x plus 7. And then square the right-hand side, square the binomial 2x minus 1. So I'll move it over here. Whoops, I forgot. We're squaring the square root of x plus 7. Okay, so when we square the square root of x plus 7, we just get x plus 7. And remember what it means to square a binomial. It means to multiply the binomial by itself. That is 2x minus 1 times 2x minus 1. So when we multiply 2x minus 1 times 2x minus 1, we get 4x to the second minus 2x, and then minus 2x again. And then finally, -1 times -1 is +1, so this is plus 1. Okay, so we'll combine like terms, so we get x plus 7 equals 4x to the second minus 4x plus 1. And then we'll subtract x from both sides and subtract 7 from both sides so that we get 0 equals 4x to the second minus 5x minus 6. So now we have to solve this equation. Well, we can use the AC method again. So multiply 4 times -6. We get -24. We want to see if we can find two integers that have a product of -24 and a sum of -5. Well, those two numbers are -8 and +3. So we'll go ahead and complete the factoring. We'll replace the minus 5x by minus 8x plus 3x. And then we factor by grouping. Out of the first two terms, we can factor out 4x. And the other factor is x minus 2. Bring down the middle operator of addition. Out of the third and fourth terms, we can factor out 3. And the other factor is x minus 2. And so the factorization is x minus 2 times 4x plus 3. Okay, so one of the solutions is x equals 2. And the other solution, when we set 4x plus 3 equal to 0, we subtract 3 and then divide by 4. So the other solution is x equals -3/4. Okay, so in this little space, if you can see it, I'll test x equals 2. and replace every x with 2. So we have the square root of 2 plus 7. And since x is on the right-hand side, we replace x with 2. So 2 times 2, I'll just write it as 4 minus 1. And we can see that this is going to be true. The positive square root of 2 plus 7 is the positive square root of 9, which is 3. And 4 minus 1 is 3. So x equals 2 is a solution. Okay, on this next this next candidate, notice we can save ourselves some work if you just notice that on the right-hand side we have 2 times x minus 1. So the right-hand side is 2 times negative 3/4 minus 1, but this number is negative. But up here we have a positive square root. So a positive square root cannot be equal to a negative number. This number is less than 0. So that means negative 3/4 is not a solution. Okay, the next example is similar to the one that we just did. So let's skip that one for now and look at the bottom one. This one, solve 3 times the square root of x equals x plus 2. Here's an example of where my suggestion is to not divide both sides by 3 first. Just start out by squaring both sides. So we're going to square 3 times the square root of x. And then on the right-hand side, we're going to square x plus 2. And remember what it means to square something. When we square 3 times the square root of x, that means 3 times the square root of x times 3 times the square root of x. So the left-hand side simplifies to 9x. And then when we square x plus 2, we're going to get x squared plus 4x plus 4. And then we'll subtract 9x from both sides, so we get 0 equals x squared minus 5x plus 4. And we can factor this. So one of the factors is x minus 1, the other one is x minus 4. Right, negative 1 times negative 4 is positive 4, but negative 1 plus negative 4 is negative 5. So the two solutions to the equation are positive 1 and positive 4. And so we'll check those one at a time. First check x equals 1. 3 times the square root of 1 equals 1 plus 2. Or 3 times 1 equals 3. That's true. So 4 is a solution. And when we test x equals 4, 3 times the square root of 4, is that equal to 4 plus 2? The square root of 4 is 2, so 3 times 2 is 6. That is also true. So this equation has two solutions. Okay, we've seen how to solve equations with square roots, but we also want to know how to solve equations with roots with different indexes. So we'll look at the next one will be a cubed root, involve a cubed root of something. Okay, solve this equation, the cubed root of 2 plus 9x equals 9. Remember that one difference between a cube root and a square root. The square root of a negative number is not a real number, but the cubed root of a negative number is a negative real number. Okay, so this one is the positive cubed root of 2 plus 9x equals 9. So this time, since it's a cube root, we want to raise both sides of this equation to the third power. So we raise the left-hand side, the cube root of 2 plus 9x, to the third, and raise the right-hand side to the third power, 9 to the third. And then when we cube the cube root of 2 plus 9x, we're just going to get 2 plus 9x. And then on the right-hand side, when we cube 9 to the third, well, 9 times 9 is 81, and then 81 times 9 is 729. And then this equation is easy enough to solve. Subtract 2 from both sides, so 9x equals 727. And then divide both sides by 9, x equals 727 divided by 9. This is an improper fraction, but improper fractions are okay. But it cannot be written in lower terms. So it's really straightforward to check this one. If you replace x with replace x with 727 divided by 9, the 9's are going to cancel, and you'll be left with the cubed root of 2 plus 727, which is the cube root of 729, and we already know that the cube root of 729 is 9. So this will work out to be the solution. Okay, in the next example, we have another cube root. The cube root of 7x plus 1 equals negative 5. Okay, if this were a square root, we would say no solution, but we can't say that there's no solution if it's a cube root, because cube roots of negative numbers are negative. So there's nothing wrong, at least at this point. So we want to solve for x, so we're going to cube both sides. That is, raise both sides to the third power. And when we raise the cubed root of 7x plus 1 to the third, we just get 7x plus 1. And the number negative 5 to the third is negative 125. And then we solve for x, subtract 1 from both sides. 7x equals negative 126. And then divide both sides by 7. Negative 126 divided by 7 is negative 18. Okay, then it's easy to check this one, so we might as well do it. Replace x with negative 18. So we get inside the cube root, we have 7 times negative 18 plus 1. And we know that the 7 times negative 18 is negative 126. So we have the cube root of negative 126 plus 1. And negative 126 plus 1 is negative 125. And the cube root of negative 125 is negative 5. So this is exactly what we wanted to see or not. And it turns out that x equals negative 18 is the only solution. Okay, the next example, this time we're not using a radical, we're using the rational exponent notation. And so y plus 8 to the 1/4 equals 2. This is equivalent to having the fourth root of y plus 8 equals 2. You can convert it to radical form if you want, but it's not required. So if you want to convert it to radical form, it would be the fourth root of y plus 8 equals 2. And since we want to solve for y, and y is inside a fourth root, well, we raise both sides to the fourth power. So the fourth root of y plus 8 to the fourth power on the left-hand side, and on the right-hand side, 2 to the fourth power. And the fourth root of y plus 8 to the fourth is y plus 8. 2 to the 4th is 16. 2 times 2 times 2 times 2 is 16. And so y equals 8. 16 minus 8 is 8. Okay, and you can pretty much verify by looking that y equals 8 is a solution. If you replace y with 8, you have 8 plus 8 is 16, and 16 to the 1/4 is 2, because 16 is a perfect fourth power. I'll just point out one more thing. You don't, like I mentioned, you don't have to convert it to a radical. But since the exponent is 1/4, we still want to raise both sides to the fourth power. So we raise y plus 8 to the 1/4 to the 4th, and raise the right-hand side to the 4th. And then one of those properties of exponents that we've had a chance to review recently, we multiply the exponent 4 times the exponent 1/4. 4 times 1/4 is 1, and so we get y plus 8 equals 16, and we get the same result. Okay, we have a few minutes to cover section 8.8, and that's all we're going to need is a few minutes. It's the introduction to complex numbers in section 8.8. So if you understand square roots, this is just a little bit more information about square roots. But this time it's going to involve square roots of negative numbers. Okay, so we already know that the square root of a negative real number is not a real number, but it is a number. It's a different kind of number. It's a non-real complex number. So each non-real complex number can be written so that the square root of -1 appears in its construction. So there's a definition. Instead of writing the square root of -1 every time we need it, we're just going to use lowercase I in its place. And that is the term that I has now is called the imaginary unit. The imaginary unit is I, which is the square root of -1. So it follows, if you square both sides of this equation, it follows that I to the second equals -1. So both of those are important to remember. I is just the square root of -1, and I to the second is -1. Okay, so we'll simplify the following square roots of negative numbers. We'll use properties of square roots that we already know. So in this first one on the left, the square root of -4, think of that as the square root of -1 times the square root of 4, because -1 times 4 is -4, and we're going to replace the square root of -1 with I. And we know that the square root of 4 is 2, so I times 2. It's more conventional to write that number as 2 times I, in the same sort of way that you would put a coefficient in front of a variable. Okay, so if you understand this example, you will understand what's behind all of the other ones. Simplify the square root of -9. I'll do it in reverse order this time. Think of this as the square root of +9 times the square root of -1, because 9 times -1 is -9. The square root of 9 is 3, and we replace the square root of -1 with I, because that's how we define I. Okay, after a while, and maybe already, you can tell by looking how to simplify the square root of a negative. So let's see if we can do this one without any preliminary work. The square root of negative 16, well, that's the square root of 16 times the square root of negative 1. And the square root of 16 is 4, and the square root of negative 1 is I. So this simplifies to 4 times I. The square root of negative 25, you can think of that as the square root of 25 times the square root of negative 1. The square root of 25 is 5. The square root of negative 1 is I. So 5 times I is how we simplify the square root of negative 25. Okay, but sometimes we'll have to do more simplifying, like this one, the square root of negative 8. So to start with, we can think of this as the square root of 8 times the square root of negative 1, just like in the previous examples. But then we can simplify, we have to do a little bit more work to simplify the square root of 8, because 8 is not a perfect square. So in the next step, we can proceed to simplify the square root of 8 and then also replace the square root of negative 1 with I. So the largest factor of 8 that's a perfect square is 4. So we can write this as the square root of 4 times the square root of 2, and then replace the square root of negative 1 with I. And then finally, we can write 2, that's the square root of 4, 2 times the square root of 2 times I. Make sure that you put the I outside of the square root. Okay, let's do a couple more of these. The square root of negative 27. Well, think of this as the square root of 27 times the square root of negative 1. 27 is not a perfect square, but the largest factor of 27 that is a perfect square is 9. So in the next step, we'll replace the square root of 27 with the square root of 9 times the square root of 3, and replace the square root of negative 1 with I. And the square root of 9 is 3, so we get 3 times the square root of 3 times I. That's the simplified result. Okay, so you probably see how to handle these. Let's do one that's a little more arithmetic involved, like the square root of negative 112. Okay, so think of the square root of negative 112 as the square root of 112 times the square root of negative 1. And we want to simplify the square root of 112, and then we will also replace the square root of negative 1 with I. Okay, so let's see. The largest factor of 112 that's a perfect square is 16, I think. Well, let's see. 16 times 7, yeah, that's going to work. 16 times 7 is 112. So we will replace the square root of 112 with the square root of 16 times the square root of 7, and then replace the square root of negative 1 with I. And the square root of 16 is 4, so we get 4 times the square root of 7 times I. Okay, I'll leave the other examples for you to do. It just involves using the square root of negative 1 equals I and what you already know about simplifying square roots. So there's a little bit more information about complex numbers. A complex number can be written in the form a plus b times I, where a and b are real numbers, and I is the square root of negative 1. The real part of a plus bi is the real number a, and the imaginary part of a plus bi is the real number b. So every real number is a complex number whose imaginary part is 0. For example, the real number 7 can be written in the form of a complex number, 7 plus 0 times I, where I is the square root of -1. Okay, we'll go ahead and stop there, and I'll email you the quiz right now. So I'm sending the quiz. So complete the quiz in 15 minutes. Email it back in the email that I just sent to you with the quiz. And we'll meet again on Monday at 8. We'll start in 1 minute. Today we'll cover section 8.6 on how to solve equations with radicals. And then we'll also cover section 8.8, which is the introduction to complex numbers. And at 40 minutes past the hour, I will send you the quiz 8 in an email, and you can either make a copy or just write down the answers. But if you write down the answers, make sure that you show work to get the answers. Test 3 will be next Friday, and it will be over chapters 7 and 8. We will go ahead and start section 8.6. Okay, it will be explained how to solve equations with radicals. After solving an equation with one or more radicals, it is important to check the answers because of the possible occurrence of extraneous solutions. An extraneous solution is a solution that emerges from a process maneuver that is not a solution to the original equation. I'll explain how to solve equations with radicals in a number of examples. So the first one, we have the square root of 3x minus 5 equals 8. This is how we want it to be. We want the square root or the radical to be on one side of the equation by itself and all other numbers on the other side. And since it's a square root of 3x minus 5 and we want to solve for x, to get rid of the square root, we're going to square both sides of the equation. So we'll square the left-hand side, square the square root of 3x minus 5, and square the right-hand side, which is 8 to the second. And when you square the square root of 3x minus 5, you're just left with 3x minus 5. And when you square 8 squared is 64. And this equation is just a simple linear equation in one variable. So add 5 to both sides, 3x is 69. And then divide both sides by 3, x is 23. Okay, so we'll check the solution. Replace x with 23. We have the square root of 3 times 23 minus 5. And inside the square root, 3 times 23 is 69. So we have the square root of 69 minus 5. And that's the principal square root of 64. And the positive square root of 64, also called the principal square root of 64, is 8. And that equals what it's supposed to, so that means x equals 23 is the solution to that equation. Okay, I'll explain something that we've talked about before, but when we square the square root of something, we just get whatever that something is. So here's the idea. If you square the square root of x, this means the square root of x times the square root of x. And the square root of x times the square root of x is the square root of x squared, because x times x is x squared, and the square root of x squared is x. But we don't need to put all of those intermediate steps. We can just go from this first term and simplify it to x. Okay, we'll do the same thing in a number of other examples. In the next one, the principal square root of 4x plus 5 equals -5. Okay, remember the principal square root is positive. There's not a negative symbol out front, so the left-hand side of this equation represents a positive number, but the right-hand side represents a negative, or is a negative. But it's never the case that a positive number equals a negative. So we can tell right from the start that this equation has no solution. Okay, well, what happens if you don't recognize that it has no solution? If you go through the same process, then you'll still be able to determine that there's no solution. It will just be a lot of extra work. But let's go through that. Since we have the square root of 4x plus 5 and we want to solve for x, we're going to square both sides. So we're going to square the square root of 4x plus 5. And on the right-hand side, we're going to square the number -5. When we square the square root of 4x plus 5, we just get 4x plus 5. And when we square the number -5, we get 25. And then subtract 5 from both sides. 4x equals 20. And then divide both sides by 4, x equals 5. So we'll go back and check in the original equation. Replace x with 5. So the left-hand side is the positive square root of 4 times 5 plus 5. Then we'll do the arithmetic on the inside of the square root. The positive square root of 4 times 5 plus 5 is the positive square root of 25, because 4 times 5 is 20, 20 plus 5 is 5. And the positive square root of 25 is positive 5. But that does not equal -5. So either way, we have to conclude that this equation has no solution. But it saves time to recognize it right from the start. Okay, in the next example, we don't have the square root by itself, so there's a preliminary step. We have to subtract 2 from both sides, and then we'll get the square root of 5x plus 4 equals 7. And now that the square root of 5x plus 4 is all by itself on the left-hand side, now we can square both sides. So we square the square root of 5x plus 4. And we set that equal to 7 squared. When we square the square root of 5x plus 4, we just get 5x plus 4. 7 squared is 49. Subtract 4 from both sides. 5x is 45. And then divide both sides by 5, we get x equals 9. So we'll go ahead and check it. We can check x equals 9 in either the original equation or this second one that we got when we isolated the square root. So I'll just check it in this one. Replace x with 9. So we have the positive square root of 5 times 9 plus 4, which is the positive square root of 45 plus 4. And that's equal to the positive square root of 49. And the positive square root of 49 is positive 7. And that's exactly what it's supposed to be. So x equals 9 is the solution to that original equation. We'll do some more examples that begin to get a little more complicated. So this time solve this equation, the square root of x squared minus 9x equals 6. The square root part is by itself on the left-hand side, so we'll square both sides. We're going to square the square root of x squared minus 9x and square the right-hand side, 6 squared. When we square the square root of x squared minus 9x, we just get x squared minus 9x. And the right-hand side, 6 squared, is 36. Then subtract 36 from both sides. X squared minus 9x minus 36 equals 0. And we can solve this by factoring. On this one, we can use the abbreviated AC method to factor x squared minus 9x minus 36. Two numbers that have a product of negative 36 and a sum of negative 9 are negative 12 and positive 3. Negative 12 times 3 is negative 36, and negative 12 plus 3 is equal to negative 9. So since the coefficient of x squared is 1, the abbreviated AC method says we can just write down the factors x minus 12 times x plus 3. And if you're ever in doubt about your factoring, you can always multiply the factors. But we can tell by looking, negative 12 times 3 is negative 36. And then negative 12 times x is negative 12x plus 3 times x is a total of minus 9x. So we did the factoring correctly. This equation has two solutions. One is positive 12 and the other one is negative 3. Okay, so we'll check both of those. We'll check x equals 12 first. In the original equation, replace every x with 12. So we have the square root of 12 to the second minus 9 times 12. And inside the square root, 12 to the second is 144. And minus 9 times 12 is minus 108. And inside the square root, 144 minus 108 is 36. And the principal square root of 36 equals 6. And that's true. That's what it's supposed to be equal to. So x equals 12 is a solution to that original equation. Now let's check the other number, x equals negative 3. So down here, square root, replace every x with negative 3. So we have the square root of the number negative 3 squared minus 9 times negative 3. And inside the square root, when you square negative 3, you get positive 9. And we're subtracting 9 times negative 3, which is the same as adding 27. So we have the principal square root of 9 plus 27, which is the principal square root of 36. And the principal square root of 36 is 6. So x equals negative 3 is also a solution. Okay, in the next example, solve the square root of x plus 7 equals 2x minus 1. Hey, this one will be even a little more involved than what we've encountered so far. But the square root of x plus 7 is by itself on the left-hand side. So we start out by squaring both sides. So square the square root of x plus 7. And then square the binomial 2x minus 1. And remember how to square a binomial. If you square 2x minus 1, it means to multiply 2x minus 1 by itself. Okay, so we'll do all of that. When we square the square root of x plus 7, we get x plus 7. And when we square 2x minus 1, or 2x minus 1 times 2x minus 1, we get 4x to the second minus 2x, and then minus 2x again, and negative 1 times negative 1 is positive 1. So the right-hand side, when you combine the like terms in the middle, you get 4x to the second minus 4x plus 1. And then now we have x plus 7 equals 4x squared minus 4x plus 1. So we will subtract x from both sides and also subtract 7. And we'll get 0 equals 4x squared minus 5x and minus 6. Okay, so I wonder if we can solve this equation by factoring. Well, let's try the AC method. 4 times negative 6 is negative 24. 4 times negative 6 is negative 24. And we want to see if we can find two integers that also have a product of negative 24 but add up to negative 5. Okay, it doesn't take too long to find that negative 8 and positive 3 are the two integers that we need. And so we'll replace the minus 5x with minus 8x plus 3x. So I'll use this little space right here to write this. So 0 equals 4x squared, but we're going to replace minus 5x with minus 8x plus 3x, and then minus 6. And then we factor this by grouping. Out of the first two terms, we can factor out 4x. So 4x times x minus 2. Bring down the middle operator of addition. And out of the third and fourth terms, we can factor out 3. And the other factor is x minus 2, just as it's supposed to be. And then finally, we can write the factorization, x minus 2 times 4x plus 3. This equation has two solutions, x equals 2. And then if we set 4x plus 3 equal to 0, we subtract 3 and then divide by 4. So x is negative 3/4. But we want to check to see if these are solutions to the original equation. So for x equals 2, we can pretty much tell by looking. Let's just imagine what happens if you replace every x with 2. So on the left-hand side, we get the positive square root of 2 plus 7, or the positive square root of 9, which is positive 3. So the left-hand side is positive 3 when you replace x with 2. And on the right-hand side, replace x with 2. 2 times 2 is 4. 4 minus 1 is also 3. So x equals 2 is a solution. Okay, the other number, x equals negative 3/4. Well, this one takes a little more work, well, sort of, in a way. If you replace every x with negative 3/4, you get the square root of negative 3/4 plus 7. And then the right-hand side, replace x with negative 3/4, we get 2 times negative 3/4 minus 1. So we already have enough information, but let's take it a step or two further. On the inside of the square root, we have to add negative 3/4 to 7, so we have to have a common denominator. And the common denominator is 4, so 7 is equivalent to 28 over 4. So we get the square root of negative 3/4 plus 28/4. And the right-hand side, 2 times negative 3/4 is negative 3/2, and then negative 3/2 minus 1. Well, I think we can point out what's going on here. The left-hand side is going to be a positive number because on the inside of the square root, we have positive 25/4. So the left-hand side is a positive number, but on the right-hand side, we have a negative number. Negative 3/2 minus 1 is negative 5/2. But a positive number equal to a negative number is not true. So that means this candidate, x equals negative 3/4, is not a solution. So I'll just note x equals 2 is the only solution. This next example is a similar type of process. Just square x plus 6 on the left-hand side and square the square root of 2x plus 12 on the right-hand side. But we'll go ahead and bypass that for now, and we'll look at this example. Solve the square root of 3 times the square root of x equals x plus 2. In this situation, my advice is to go ahead and square both sides as they are instead of dividing both sides by 3 first. And the reason that I make that suggestion is that even though you can divide both sides by 3 first, eventually you're going to have to undo that in this case. So if we just square both sides, square 3 times the square root of x and square x plus 2, when we square 3 times the square root of x, we're going to get 9x. So just remember, this means to multiply 3 times the square root of x times 3 times the square root of x. So 3 times 3 is 9, and the square root of x times the square root of x is x. And on the right-hand side, when you square the binomial x plus 2, you're going to get x squared plus 4x plus 4. Okay, so we'll solve this equation for x, subtract 9x from both sides, and we get 0 equals x squared minus 5x plus 4. And it's pretty easy to see how to factor the right-hand side. The two factors are x minus 1 and x minus 4. So this equation has two solutions, x equals 1 and x equals 4. But we'll check in the original equation. First, we'll check x equals 1. So 3 times the square root of 1, replace every x with 1. And the square root of 1 is 1, so 3 times 1 equals 3. That's true. So that means x equals 1 is the solution. Then check the other candidate, 4. Replace every x with 4. So 3 times the square root of 4 equals 4 plus 2. Square root of 4 is 2, so 3 times 2. And 4 plus 2 is 6. That is also true. So both of those are solutions to the original equation. So far, we've only encountered square roots when solving equations with radicals, but there are other equations with different indexes for radicals, so we have to look at some of those next. Okay, this time we have the cubed root of 2 plus 9x equals 9. The cubed root of 2 plus 9x is by itself on the left-hand side, so we can raise both sides to the third power to get rid of the cubed root. So we're going to raise the left-hand side to the third power, and we're going to raise the right-hand side to the third power. We're doing the same thing to both sides. But when you raise the cubed root of 2 plus 9x to the third power, you're just going to be left with 2 plus 9x. And when you raise 9 to the third, that's just 9 times 9 times 9. 9 times 9 is 81, and 81 times 9 is 729. And then we'll solve this for x, subtract 2 from both sides. So we get 9x equals 727. And then divide both sides by 9. X equals 727 divided by 9. This number is written as an improper fraction, and that's fine. It's a perfectly fine answer. But this fraction cannot be written in lowest terms. Okay, so if you check, this one doesn't take long to check. Just replace x with, whoops. So inside we have 2 plus and then 9 times 727 over 9. And then inside the radical, the 9 times 727 over 9, the 9's cancel, so we're just left with 2 plus 727 on the inside. And that's equal to the cube root of 729, but we know that the cube root of 729 is 9. That is equal to what it's supposed to be equal. And so this is the solution to that equation. Okay, the next example also involves a cubed root, and it's by itself on the left-hand side. So we have the cubed root of 7x plus 1 equals negative 5. Okay, remember the difference between a cube root and a square root. The cube root of a negative number is equal to a negative number. So there's nothing wrong with this, at least right now. There's nothing that we can see that's wrong with saying that the cube root of a number equals negative 5. Okay, so to solve for x, we're going to raise both sides to the third power. So the left-hand side is the cube root of 7x plus 1 to the third power. And the right-hand side, the number negative 5 is raised to the third power. When we raise the cube root of 7x plus 1 to the third power, we just get 7x plus 1. And the number negative 5 to the third is negative 125, because that's just negative 5 times negative 5 times negative 5. Then we'll solve this equation for x, subtract 1 from both sides. 7x equals negative 126. Then divide both sides by 7. Negative 126 divided by 7 is negative 18. Okay, so this only takes a few seconds to check. In the original equation, replace x with negative 218 or negative 18. So we have the cubed root of 7 times negative 18 plus 1. And 7 times negative 18 is negative 126. And so on the inside, we have the cube root of negative 126 plus 1. And that's the cube root of negative 125 And we know that the cube root of negative 125 is negative 5. And that is equal to what it's supposed to be equal to. So this equation has one solution. Okay, the final example in this section, 8.6, we have y plus 8 raised to the 1/4 power equals 2. If you want, you could rewrite this in radical form. It's just the fourth root of y plus 8 equals 2. And then you can raise both sides to the 4th power. So if you raise the 4th root of y plus 8 to the 4th power, then raise the right-hand side to the 4th power. And then the 4th root of y plus 8 to the 4th is just y plus 8. And 2 to the 4th on the right-hand side is 16. And y equals 8 is what you get. And it's easy to check that this is a solution. Replace y with 8. So we get 8 plus 8 to the 1/4. And that's 16 to the 1/4. But 16 is a perfect 4th power, and 16 to the 1/4 is 2. Okay, but I also just want to show you what to do. You don't have to convert it to radical form. Since the exponent on y plus 8 is 1/4, we can just raise both sides to the 4th power, just like we did when it was in radical form. Raise both sides to the 4th power. Okay, and then one of the properties of exponents that has come up a number of times in recent days, if you have something raised to an exponent, and if that entire term is raised to an exponent, you can just multiply those exponents. 4 times 1/3 is 1, so this just becomes y plus 8 to the 1st, or y plus 8. And then 2 to the 4th is 16. And then subtract 8 from both sides, you get y equals 8. So either way is okay. We'll spend a few minutes on section 8.8, and it won't take very much time to cover what we're going to cover in section 8.8. Okay, in section 8.8, this is called the introduction to complex numbers. Starting at the top, we know that the square root of a negative real number is not a real number, but it is a number. It's a non-real complex number. So each non-real complex number can be written so that the square root of -1 appears in its construction. So rather than always writing down the square root of -1 when we need to, or when it's needed, we're just going to write I in its place. So this is the definition. The imaginary unit is lowercase I, and it just represents the square root of -1. Okay, so it's going to be easier to write I instead of always writing the square root of -1. And since I is defined to be the square root of -1, if you square both sides of this, it follows that I to the 2nd equals -1. Both of these two equations are important to remember. Okay, then we can use what we know about simplifying square roots to simplify square roots of negative numbers. So let's start out with simplifying the square root of -4. Okay, well, -4 is 4 times -1, so we can think of the square root of -4 as the square root of 4 times the square root of -1, because 4 times -1 is -4. We're just applying the product property of radicals when we do that. We can simplify the square root of 4, that simplifies to 2, and then we're going to replace the square root of -1 with I. So the square root of -4 simplifies to 2 times I. And that's all there is to it. So we'll do a few more. The square root of -9, using the product property of radicals. Think of that as the square root of +9 times the square root of -1. The square root of +9 is 3, and we replace the square root of -1 with the letter I. So the square root of -9 simplifies to 3i, 3 times I. Okay, after a while, and maybe already, you can tell by looking what the square root of some negative number is going to simplify to. So let's do this in a couple of examples. The square root of -16 is equivalent to the square root of +16 times the square root of -1. And the square root of 16 is 4, and the square root of -1 is I. So in other words, the square root of -16 simplifies to 4 times I. The square root of -25 simplifies to 5i. Okay, they won't all be that easy. If we know how to simplify square roots in general, though, it won't be too bad. So let's simplify the square root of -8. So think of the square root of -8 as the square root of 8 times the square root of -1. And we're going to replace the square root of -1 with I. And then we know how to simplify the square root of 8. The largest factor of 8 that's a perfect square is 4. 4 times 2 is 8. So we'll think of the square root of 8 as the square root of 4 times the square root of 2. And we replace the square root of -1 with I. And then the last step, the square root of 4 is 2. So 2 times the square root of 2 times I. If you write it this way, make sure that the I never is inside the square root. Okay, let's do a couple more examples. Let's try the square root of -80. Well, you know how to think about that. Think about that as the square root of 80 times the square root of -1. The largest factor of 80 that's a perfect square is 16. 16 times 5 is 80. And we will replace the square root of -1 with I. So in the next step, we can write the square root of 16 times the square root of 5 times I. And then in the final step, the square root of 16 is 4. So we get 4 times the square root of 5 times I. Sometimes you'll encounter big numbers, but they aren't really that hard. Like this one, the square root of -500. So we can write that as the square root of 500 times the square root of -1. The largest factor of 500 that's a perfect square is 100. So we can rewrite that as the square root of 100 times the square root of 5, and then replace the square root of -1 with I. And then the square root of 100 is 10. So our final result is 10 times the square root of 5 times I. Okay, I'll leave the other ones for you to do. Those aren't really too hard. But here's a little bit more information about complex numbers. A complex number can be written as a plus b times I, where a and b are real numbers, and I is the square root of -1. The real part of a plus bi is the real number a, and the imaginary part of a plus bi is the real number b. It's the coefficient of the imaginary unit. And every real number is a complex number whose imaginary part is 0. So for example, the real number 7 can be written as a complex number, 7 plus 0 times I, where I is the square root of -1. So this just means that the real numbers are a proper subset of the complex numbers. And the non-real complex numbers all involve the square root of a negative number. Okay, so let's stop there and start the quiz. I'm going to email the quiz right now. And so I just emailed it. So you can either make a copy and then finish the quiz and then take a picture, or you can complete the quiz on paper and take a picture of that and then send that. But when you're showing your work, make sure that you don't just write answers. Make sure you write all of the work or a sufficient amount of work to get to the answer. Okay, so that's all for today. I'll talk to you again on Monday.